Okay, here we go. This is part 2 of section 13.3. Let me get the pen going. We're going to talk about these things called, and I rarely ever, if ever, refer to this stuff with this word, but they have it in there. Oh, by the way, I don't know if it's this class, but one of my classes, I was looking at it again last night to make sure everything went on there, and I misspelled a word. It was so embarrassing. I wanted to go. Of course, nobody's looking at these anyway, so it really doesn't make any difference. I act like all kinds of people are even looking at these, but anyway. You do? You lying? Did you really?
Yeah. They said you came pretty well.
Okay. Nah. Are you just saying? You're just.
I'm dead serious.
Oh, I know, yeah.
Okay. All right. That's fine. I don't mind. It's just, I was just surprised that somebody would do that.
He's like dying.
He's becoming a YouTube star.
Yeah, I'm famous. All right, here we go. Now, I told you before, my biggest worry is that some real smart math teacher is going to write me or something like that and just tell me how bad of a teacher I am. You know, what's that? Well, it's a little different because this is a live thing. It's not just, you know, and it's going from a certain curriculum. All right, so let's do 4 of these. Oops. Come on, grab it. It's right there. And let's put this one, let's put it right here, spread them out a little bit. All right, this is really not that big of a deal. It's kind of easy to understand, I think. What we're going to do is, like that one that we did before, that angle went through, it like went in the middle of a quadrant, thank you, Dallas. So it went through the middle of a quadrant. But not every point does that, right? I mean, -4 or what was it? -3, -4 actually hit, you know, inside here somewhere. But sometimes it lies right on the axis itself, doesn't it? Right? Sometimes it could be like right here. You with me? So what we want to do is we want to find the sine, cosine, tangent, and the other, the other 3 are just the inverses, not that big of a deal. But we'll go sine, cosine, tangent of something right here, whatever that point is. This could be like, give me an example of what this point could possibly be. I know I didn't put any numbers on there. 5, 0, give me another one. 7, 0, 2, 0, anything 0, right? Okay. It could be pi 0, 22, 0. All right. We're getting carried away. So it could be anything 0. Would you agree? So what we want to do here, and I'm going to, let's see. Oh, I'm hitting the wrong key. There I go. I'm going to make this a little bit thicker just so that we can see it. All right? So what I'm going to do is I'm going to draw the line to here. All right, there you can see it pretty well. And you can't really draw a triangle out of that, can you? Remember when we did the one down here? We drew a triangle and we dropped it up to the x-axis. You can't really do that here. So it might be a little bit more difficult to figure out what the sine, cosine, and tangent at that particular place is. By the way, what's the angle right here?
0?
It's 0 degrees, isn't it? Okay, so you can't really make a triangle out of that, but you can figure out what this, actually we've been doing sine first, it doesn't make any difference, but the sine of 0 degrees, the cosine of 0 degrees, and the tangent. Now watch, I'm going to show you something here that I'm not really going to give you a great explanation for, because I'm going to save it for another lesson. We're going to have a lesson in a few lessons from now. I think it's like, this is 3, 4, 5, 6. I think it's like 13.6, where we are going to talk about something that's called the unit circle. All right? The unit circle is really important. I really wish they would teach it like right now at this point. They wait a few lessons. I think it's okay to teach it now. I guess they're trying to just get you warmed up for it. But on the unit circle, this spot right here is not 5, 0, 6, 0, 7, 0. It's 1, 0. All right, we'll talk about this a little bit more. But I'm going to show you something that let's do this over here. I got some room. And that pen's a little too thick. There we go. Watch this. I'm going to show you something that the sine, let's just do a really, oh my, a little swooshy, but it's supposed to be straight. Okay, you get the idea. Watch, if this was theta right here, and this is opposite, I'm going to call that y, call this x, and call this r. R for radius of a circle, because it could make a circle. Now, what's the sine? The sine is the opposite over the what? Hypotenuse. So the sine of an angle is equal to, what would you put here? Y over r. The cosine of the angle would be what?
Y over.
It'd be adjacent over hypotenuse, or x over r. Then the tangent of the angle, oops, that's a terrible A, is going to be the opposite over the adjacent, which would be y over x. Okay. What's that? The Sohcahtoa thing? Yeah. Now, after a while, you hardly even have to think about it, do you? Okay. At first, definitely, it's a big help, the Sohcahtoa. But after a while, you just kind of remember what it is because you're going to do them so much. Now, let's come over here. Now, this point right here, you could call it anything. You guys were calling it 5, 0. Doesn't matter. Let's call it 5, 0. So 5 is the what? 5 is the x. 0 is the what? Is the y. What do you think the r is in this situation? Because it doesn't really angle up to make a hypotenuse. But really, where does the hypotenuse go? It goes from the origin out to where the end of the point is, doesn't it? So what do you think the r is in this situation? It would be 5, exactly. Okay, so I can even write that down. I can put r is 5. So let's use this stuff right here that we've learned to figure out the sine, cosine, and tangent of that particular place. You with me? Okay. So the sine of 0 is the what? Y over the r. So what's the y? 0 over what? 5 over anything. Doesn't make any difference, does it? What about the cosine? The cosine is x over r. So x is 5 over r, which is 5. 5 over 5 is 1. So the cosine of 0 is 1. Who's got a calculator? Punch those in. See what it works. What about the tangent? The tangent is y over x. So y is what? 0. Y is 0, right? According to this point right here, we said it's 5, 0. So the y is the 0 over the x, which is 5. What's 0 over 5? It's 0. All right? Check those in your calculator. Are you doing them?
Yeah.
All right, so good thing this thing can't see my facial expressions right now. I won't even say who it is. All right. Okay. All right. All right. So anyway, try it. Would you agree sine of 0 is 0?
Yes.
Yes. And the cosine of 0 is 1. Did you do that on your calculator?
Yes,
And the
sir.
tangent is 0. All right. So that's at 0 degrees. Let's do the others a little bit quicker now. Let's do one at this angle right here, which would be 90 degrees. All right. Yeah, we can pick any number, but you realize that it's going to be 0 something, isn't it? It's going to be 0 whatever, okay? Sarah said 6, we'll use 6. All right, so there's the thing right here. Now, if I was going to do sine, cosine, and tangent, I'll just do S. We're running short on time. The sine would be what? Well, no, let's use this, remember? The y over the r. So the y is 6 over the r, which is what? 6, right? And that's equal to 1. So the sine of 90 degrees is 1. This is not really a good way to write this. Some teachers would have a fit probably if they saw me doing this. All right, but the cosine is what? It's x over r, which is 0 over 6, which is 0. Now watch this one. This is a little funky. Watch. The tangent, I even wrote it out. The tangent of 90 degrees. Since this comes out a little weird, I'll write the whole thing out. The tangent of 90 degrees is what? Y over x. Look at that. Is something crazy going to happen here? What's 6 over 0? It's undefined, isn't it? Try that on your calculator. You can't divide by 0, okay? It's undefined. We've talked about it before. Sometimes we write it like this, all right? Empty set, null set, right? It's the same thing as saying undefined. Try it on a calculator. Put tangent of 90 in the calculator, see what you get. Right, it says error, doesn't it? And sure enough, it is. So look, we're doing all this stuff without a calculator, aren't we? We're figuring all this stuff without punching it in a calculator. The only reason I'm asking you to put it in a calculator is just to, you know, just to see what you're going to get. Now watch. No, it doesn't. You don't have it in, you probably have it in radians. You probably have it in radians. You got to change it to degrees.
Oh.
Yeah, there you go. Okay, watch 180. Now look at this. The sine of 180, cosine of 180. I'm not going to do this for the other one just because of time, but you could figure that out yourself. Tangent of 180. Now remember what this, let's make up a point, -3, 0, okay? So let's do the sine of 180. The sine is y, which is 0, right? 0 over anything is 0. The cosine of 180 is x over r. So it's -3 over 3, so the cosine is -1, correct? Remember the r is always positive? The tangent of 180 is y over x, 0 over -3, which is 0. Punch those in a calculator, and I bet you get that same answer, okay? You could do that with 270 as well, but we just ran out of time. All right, let me see what else we have to hit. And class is about to end anyway, isn't it? That's all right. I can actually go, I figured out you can go to 11 minutes. Okay, so yeah, your homework. There is something I'll tell you what, there's a little bit left over, but if you, this is what I want you to do. I want you to go to the Part A class. We did get to that, okay? We just went a little slow in here today. We got a slow start. Go to the Part A class and then and look to how to do the next couple examples, okay? I think I have one example on there because I just didn't hit it today. I'm going to stop this and I'll write it up. Actually, we're doing 15 to 32. I got to finish before it gets to 11. And then 37 to 46. All right? All right, say bye. Hurry.
Bye.